All right, we have a new term in this second part of 12.5 geometric series, and it is annuity. An annuity is a sequence of equal investments made at regular intervals. Let me show you all how we find the future value of an annuity. It is given by the following formulas. The one on the right has been simplified some just by factoring, and the one on the left works as well. Now each of those letters has a meaning. The P is the periodic payment amount, the I is the periodic interest rate, and N is the number of periodic payments. So everything is in terms of the period that we're working in. Let me show you how this works with some real numbers. We want to determine the value after 40 years have passed of a $75 monthly annuity which pays 4.8 APR, compounded monthly. That APR means annual percentage rate. So that's over the whole year, it's 4.8, but we have to look at it in the periods that we're talking about. So we have to determine the monthly interest rate. We know the yearly, but we need to know monthly, and the total number of payments. Our interest rate is our APR divided by 12, which gives us 0.004. Pretty small seeming number. And then the number of payments, well, it's 40 years, but each year it's done 12 times. It's compounded monthly. So that means there are 480 total payments made. So now, with that information, we substitute it into the formula. 75 is that payment. We plugged in the monthly interest rate and the N, which is the number of payments, and take a moment to plug that into your calculator. You should find it to be $108,654.10. Pretty substantial chunk of change. All right, I want to talk now a little bit about this infinite geometric series. Remember, infinite means that it keeps going, that it's never ending, that there aren't just like 10 terms or 100 terms or even a million terms. It continues on and on and on for infinity. Now, if you're working with a geometric series and the absolute value of the rate is less than 1, that means it's going to be like a fraction, like 1/2 or -1/3. When you take that rate and raise it to the position, it's going to keep getting smaller and smaller and smaller because the denominator is getting to be larger and larger and larger. So it's getting smaller and smaller and smaller. It's getting to be pretty much 0. And what's fascinating is that if you take and look at all of these and you were to line them up, what we call that is it's converging to 0. They're all just kind of like getting closer and closer and closer to 0. Now, conversely, if your rate is greater than 1, like a -5 or a 10, it is not going to approach a number, but it's going to go to infinity. It's never going to approach something and get closer and closer. It's just going to grow exponentially. And we call that diverging because it's not going towards something, it's just kind of going off, diverging. And if you took and tried to add all the terms here, you wouldn't be able to. It does not have a limit. But with those that the rate is less than 1, it converges. The actual sum is going to be that first term's value divided by 1 minus r. That's going to give you the sum of that entire sequence, which seems crazy that you can add an infinite number of numbers and actually get one number. But because they're getting so small and they're pretty much 0, that's why you're able to. And like we said just a moment ago, if your rate was greater than 1, it will diverge and you won't be able to find the sum. So let's look at an example of this. We're going to determine if it's converging or diverging. And if it does converge, we're going to give the sum. Okay, so we're looking at this series here. It's 1 and then negative 1/2 and then 1/4 and then negative 1/8, then it continues on, and we're trying to add those together and determine if we even can. To do so, we need to figure out what's our rate. Well, each time it's being multiplied by negative 1/2. Negative 1/2, if you take the absolute value, is less than 1. So notice each time they're getting smaller and smaller and smaller and smaller. And what happens is it's going to converge, and the sum is 1, that's your first term's value, over 1 minus the rate. We can simplify those two negatives and it becomes positive, giving us 1 over 3/2, multiply by the reciprocal, and this series is going to have the sum of 2/3. It's really fascinating to me that you can, even though you couldn't even count all of them, you can find their sum. And there it is. Now let's look at this. We have another series. Now it's just written in sigma notation. And our rate here is 3. Because the rate is 3, that's greater than 1, it's going to diverge. You could not give the sum of all of those infinite terms. And that is all. So we will finish up this video at this time. Thank you.